So our next speakers are Robert Freese and Alissa. Robert Freese is a project manager for restoration at Irvine Ranch Conservancy. Robert has a PhD in soil science from NC State University. He has 9 years experience planning and overseeing restoration projects in both the southeastern US and Southern California. Before becoming a restoration ecologist, he worked as a soil scientist for the USDA Natural Resources Conservation Service, as an eco-hydrologist for St. Johns River Water Management District in Florida. And Alissa, she's the principal environmental planner, habitat restoration expert. She is the owner of Sage Environmental Group with 23 years of experience in Southern California. She is a BS in environmental science from UC Riverside. Her company's projects involve habitat restoration, vegetation management, integrated pest management, biological resources, CEQA, NEPA, documentation, regulatory permitting, and compliance for Conservancy, open space, public works, fire department, water, transportation, and land development projects.
So we'd like to share with you a little bit about our experiences with goat grazing over the past couple of years. Okay, so we've had several partners in the collaboration. It's not just Alissa and I, by any means. And we've got 2 experiments that we want to share with you this morning. The first involves using grazing as a tool for maintaining an established native grassland. And then the second case involves grazing as a site preparation tool for a highly degraded site. The first site, B-Flat, it's an Orange County Parks property where IRC, Irvine Ranch Conservancy, has been restoring native grasslands for the past several years, part of an Orange County Transportation Authority mitigation project. We have noticed a pattern with our grasslands where the needlegrass establishes really well the first year, but then shows signs of deterioration after a few years with accumulating thatch and encroaching annual grasses. So in this earlier restoration effort shown on that top tier of photographs, we had a full-scale reinvasion of annual grasses by year 5. Now the bottom tier of photographs shows our study site. It was very successful bunch grass establishment in the first year, but by year 3 we were seeing those same patterns of deterioration. Based on our experience with the earlier phase, we knew we needed to manage these sites a little differently. Now, rangeland scientists have known for a long time about the importance of grazing, but I think it's less widely appreciated among restoration ecologists. However, as a general ecological principle, we know that periodic disturbance is important for maintenance of diversity. And this is probably true in lots of habitats, but especially in grasslands. Now, we don't really know the extent to which large grazers were important in maintaining prehistoric Southern California grasslands, but we do know that our present-day grasslands are really a hybrid ecosystem of natives and non-natives. And as restoration ecologists, we want to shift that balance back toward the natives. It seemed to us that careful timing, duration, and frequency of grazing might be able to help us achieve that goal. And I became interested in grazing and mechanical dethatching of grasslands as a means to disrupt the annual grass thatch cycle. Because we noticed that when we raked annual grass into windrows, the next year the only thing that came up in those windrows was annual grass. So apparently it's able to germinate under very low light conditions. And of course, annual grass produces a lot of thatch. And now we also hypothesized that thatch can suppress tillering and thereby decrease the vigor of our native bunch grasses. Now this last photo on the right there shows a comparison of thatched versus dethatched areas. The thatched areas on the left, only non-native grasses. The dethatched areas on the right have a more diverse mix of grasses and forbs.
In assisting IRC, you have to ask, why use goats to graze? One of the reasons is that they are widely available. They're used in fuel load reduction. They're relatively easy to transport. In the setup, we use an electric fence. It's an on-off that's solar powered to contain the herd, which can be set up fairly easily. They work on very steep slopes, so a lot of the areas, some of the reserves, have very steep slopes that aren't readily accessible to weed whacking or mowing, and goats can address those areas. They're also charismatic. The public does very much enjoy visiting these sites and seeing the goats out in the landscape. It's something that's very well received. On the 2 sites that we worked on with IRC, these were the weeds that were addressed successfully by goats. They're able to consume, and the important point is that these herbivorous animals actually consume the vegetation. It just doesn't just lay down and contribute to the thatch layer. We've got artichoke thistle. Black mustard was their absolute favorite. They go crazy over black mustard. They also address the ripgut brome, consuming that, the wild oats, wild radish. They like that down to actually eating the root of the radish. We're working in sensitive habitat areas. We do some preclusionary measures. The biggest slide shows the fencing. It's actually a mesh that rolls up, and that's our solar panel. We also do a series of paddocks so we can control the intensity of the grazing and also control the amount of animals we have in the various areas to meet the grazing objective. Bottom photo shows how the native plants were protected successfully with the electric fence. The operation side, there are predators in these environments, bobcats, sometimes mountain lions, packs of coyotes. So we do employ our livestock guardian dogs. We have Great Pyrenees and also Commodores. These are our friendly dogs. They're Tuffy and Duke. They like people. So when people come out to these sites, they can interface with the dogs safely. This next photo shows one of our trailers. And we do quarantine our animals before they go from site to site, and we also do some hoof trimming and treatment so that we're not transporting the weed supply, seed from one site to another. We also provide additional supplemental protein and have an on-site vet tech. Timing of the grazing is important, as was mentioned before. When we graze too early, we could miss the seed head consumption, which is a really important part of what goats can do. If we overgraze, leave them out too long, they can actually degrade the lands, as a lot of the ongoing historic cattle ranching is done. So what we're finding is if we bring in our herd, we look at the stocking rate, and we want to be in and out earlier than the native forbs are actually blooming and consume the non-native seed head is our goal. We also do some fall for the forbs for fuel mod control because these animals will eat 12-foot tall mustard down to the ground and it's no longer lying there.
Okay, back to B-flat. So in year 4, 2018, we shifted our management focus from controlling weeds to managing thatch. And the hope was that we would create conditions that were more conducive to native bunch grasses, less conducive to annual grasses. And this partly involved introducing a goat herd for 10 days in late April. You can see the grazed area in the background, the area to be raked in the foreground on that left-hand shot. Now, we had a staging area at one end of the site where we unfortunately had some localized impacts, heavy trampling, overgrazing, so we weren't really anticipating that at the time. One thing I learned is that goats don't consume thatch. They trample it into the ground and abundantly fertilize it, and that, I believe, promotes the decomposition, which is just as good a way to get rid of the stuff. On that lower right-hand picture, you'll see the site post-grazing. The annual grasses were grazed and the goats pretty much left the needle grass alone. Here are vegetation cover data from this site separated into 4 functional groups, and we monitor every 2 years. In year 1, we had dense cover of needle grass, over 90%, significant cover of non-native grass, few forbs. Year 3, the needle grass was declining, the annual grass was increasing, still no forbs. Year 4, we changed our management approach. And by year 5, the needle grass cover was back up over 90%. Non-native grass decreased from 40 to 10%. We had a significant amount of forbs. These are overall data that can also be separated by management approach, since about half of our permanent sample points were in the grazed area, half were in the raked area. So here's how the site looked 1 year post-grazing. The grazed area is in the background. The raked area, where we dethatched manually, is in the foreground. Obvious difference is the grazed area had a lot more forbs. Here is how the data looks for the 2 zones. Comparing, what we're doing here is comparing between our cover measurements from 2017 and 2019. 2017, 1 year pre-grazing, 2019, 1 year post-grazing. And those are good years to compare because they're both abundant rainfall years. And so what we see is that the native grass cover in both grazed and raked areas increased modestly. The native forage cover in the grazed area showed a big increase, less so in the raked area. Non-native grass, not much change in the grazed area, surprisingly. But in the raked area, it dropped from 54% cover in 2017 down to 7% cover in 2019. So that was kind of a surprising, unexpected result, and it may be that raking stimulates the native bunch grasses or creates conditions less conducive for the annual grasses, or maybe that the raking sort of concentrates the annual grass seeds. The Center for Environmental Biology from UCI is also monitoring these sites. They have seen that the thatch mat thicknesses, we've got data from 2 months post-grazing and 14 months post-grazing. We see an immediate reduction in thatch thickness from mowing and raking, not surprising. Less dramatic from grazing, but 1 year later, they're pretty much the same. So supporting that idea that decomposition from the trampling is an important pathway for removing the stuff. Here's how the site looked. Just recently, it's now a dense cover stand of needlegrass with occasional patches of forbs, some dense tarweed patches developed in those disturbed areas. That really comes up well when you disturb it either through overgrazing or some of those were annual grass patches too.
So the grassland restoration project described in case study 1 was super successful. The grazing removed the thatch and increased the absolute cover of needlegrass from 83% in 2017 to 91% in 2019. Even more impressive is that the non-native vegetation, which was mostly annual grasses, decreased from 39% to 20% absolute cover. So that grazing created these openings where we were able to go in and introduce a variety of native forbs. The grassland site had been pretty much a monoculture of just grasses in 2017, but by 2019, we had something that looked more like a true grassland with scattered patches of native forbs, especially Denandra fasciculata, Amsynchia menziesii, Schultzia californica, and about 5 or 6 other forbs in significant quantities. So we were very happy with how this site turned out, and the agencies signed off on it as fully successful just a few months ago in July of 2020.
Our conclusions from the first project are basically both grazing and raking reduce the thatch thickness, and that seems to persist. The goats dethatch not by consuming but by trampling. Carefully timed grazing in mid-spring can impact the non-native grasses with little harm to the needlegrass. However, you have to be careful about localized impacts from grazing. Thatch disruption seems to increase your forb cover. Raking seems to benefit the needlegrass while decreasing non-native grass cover. And there's some further study areas that we need to look at. I want to move on to our second study site. We want to see if medium duration grazing could be used to prepare this site for restoration and prevent weeds from setting seed. So we introduced 65 goats in late April, later than we intended. Since the grasses were already setting seed, we divided the site into 3 enclosures, cycled the goats through. So what we saw is basically we went from a non-native grass and forb-dominated area, and the goats grazed it down to nothing. The twice mowed areas, we got some resprouting, so that was a less effective procedure. The grazing effectively reduced the thatch layer and eliminated the weed canopy.
Our second case study is really more of a work in progress at this point. However, preliminary results look promising, and the extent of grazing was expanded in 2020. We found that 1 season of grazing was enough to reduce the extent of annual grasses that germinated the following spring. Unfortunately, the extent of non-native forbs was still pretty prevalent that following spring. So the lesson there is that additional seasons of grazing are going to be needed for control of those problem weeds. As an interesting aside, we noticed that once we removed that thatch layer, we had a proliferation of native annual forbs at the site, mostly doveweed and a couple others. And while that wasn't really our ultimate objective for restoration of this site, it was an interesting lesson that you never quite know what's lurking in the soil seed bank of these thatch suppressed sites. And as always, the restoration is full of surprises, as we've learned.
Conclusions are that grazing for 1 month period eliminated the weed canopy, reduced the thatch layer, only minor resprouting of annual grasses. Broadleaf weeds, they require a little bit of follow-up treatment. No indication of viable seed in the goat droppings. In balance, we think that so far this could be a viable approach for restoring areas.
We tried to see if goat poop would sprout. We did a test. The slide has the sprouts or soil with seed that was purchased. The middle slide has the introduction of the goat droppings, and the only thing that sprouted was the purchased seed. And then the last one is just soil with the goat droppings and nothing sprouted. We do want to do more of these in our various sites so that we get a good record of it. We are interested in participating in some kind of a research with that goal in mind.
We compared 3 different treatments, the tractor mowing and raking, which works great on level ground. But if you're not on level ground, it seemed in our part of the world, the options were either weed whipping or grazing. Basically what we found is that per acre costs for the weed whipping and raking and the grazing were pretty similar. Grazing was maybe a little cheaper, but you have substantial mobilization costs, which make it actually a more expensive option. And it's only when you're dealing with relatively larger sites, over 10 acres is kind of our rule of thumb, where you might think that grazing would be economically advantageous versus mowing and raking. Benefits of grazing: that consumption of the seed heads is very beneficial since it reduces likelihood of resprouting. Consumption of biomass, you don't have to dispose of that thatch material. Nutrient recycling and public relations benefits, no small consideration on public lands. So thank you very much.